This video is an overview of the big ideas in problem 5.1 from KHM. This problem investigates reflecting an object over lines of symmetry in a coordinate plane. So you might want to write reflections right under the title of your lab sheet. And the first thing we did in part A1 was we remembered how to draw an object using those command prompts. The main item to be reflected in this problem is a flag. Now a computer would look at this flag as not a flag but as a series of 3 lines. So we've learned how to write command prompts to draw the line segments that make up an object. So in this particular case we're going to draw this line, and this line. So that's done on this key here. One of the lines is drawn from 0, 0 to 5, 5, another one from 5, 5 to 5, 3, and then from 5, 3 to 3, 3. And together those 3 line segments make up the flag, which is our original image, our original figure rather, that we will make images of. So now once we've drawn that flag, our next task is to reflect that flag and make an image of it, reflected over different lines of symmetry. In A2, we reflect it over the y-axis. And remember, when you're reflecting an object over a line of symmetry, the image of it is a mirror image of the original. It's an exact copy that you would see in a mirror, or if you folded your paper, you would have an exact copy overlapped on top of the other copy. So now in our figure, you will see not only the original flag, but the image of the flag reflected over the y-axis. Then next in A3 we're going to reflect that same flag over the x-axis. So we'd put a mirror in a different location or fold the paper on a different line. And then finally the last one, the hardest one for A4, is we're going to reflect that same flag over the line called y equals x. Now y equals x is a line that we need to be familiar with. In slope-intercept form, that would be a line that had a y-intercept of 0 and a slope of 1. And basically it's a diagonal line that runs right along here. And so we're going to reflect our flag over that line. You'll notice that in this case, the flagpole itself is part of that line, or resting right on that line. So really the only thing it reflects is the flag. So our original image here reflects over that line right here. In the next section of our problem, you're given a bunch of coordinates on a grid, and they're all labeled A through H. And your first task is to write down the coordinates of that, and we've made a table for that purpose. So you put your original coordinates in this column, and that would be part B of this problem. Now part C, D, and E are going to ask you to reflect each of those coordinates over a different line of symmetry. The first task with these coordinates is to reflect each of them over the y-axis. That's in part C. So we reflect again each point over this y-axis. So for example, point D would be reflected to right there. And so if the original coordinates of point D were 1, 2, then D prime, its new image of that point, would be negative 1, 2. And that's what I'd write in this column for the new coordinates. We're going to reflect each point over the y-axis. So likewise, we would have point F right here reflecting over the y-axis, going over right about there, which would be at 2, negative 4. So it went from negative 2, negative 4 to positive 2, negative 4. So the important thing in this problem is to investigate the general rule, or the rule that happens every time I reflect coordinates over the y-axis in this case. We want to come up with a pattern that happens so we can remember what the rule is. And we can do that by looking at the coordinates that we've come up with. If we compare the original coordinates of my points to their images under that reflection, we notice something that always happens. And we write that mathematically as shown under the rule part here. X, Y, or the coordinates, transform or turn into the opposite of x, y. Which means when I reflect something over the y-axis, the x-coordinate is always going to turn into its opposite, and we're going to keep the y-coordinate the same, which makes perfect sense if you look at d and d prime that we looked at earlier. The x-coordinate is going to flip the same distance from 0 as its original coordinate, but the y, or the vertical distance, is not going to change. So we see how the x-coordinate went from 1 to the opposite of 1, or -2, and the y-coordinate on D went from 2 and it stayed 2. So D prime is also 2. And that works no matter where you reflect the points over the y-axis. Another example used was F, -2, -4 would transform to the opposite of -2, which is +2, and it would stay -4 for the y-coordinate. So next we look at a rule for reflecting things over the x-coordinate. And once again, we write the original coordinates, which would be the same as part C, and will also be the same for part E. And then we look at new coordinates, and we reflected them over the x-axis, and those are in this column. And once again, we look for a general rule, and this time it's similar but different. This time our original coordinates transform into x opposite of y. So this time when we're reflecting over the x-axis, our x-coordinate stays the same, but our y-coordinate changes to its opposite. Now that makes total sense for us in this problem. If we look at C and C prime, here's C prime, and if you look at the coordinates, x is 3 and y is 3, and then the new coordinates are x is 3 and y is -3. So x stays the same and y changes. And again, that makes sense because the x-coordinate moves the coordinate horizontally left and right, and since we're not moving left and right, we're reflecting over the x-axis. The only movement would be on the vertical plane, moving up or down, which is what happens with the y-coordinate. So finally we look at what happens when we have a reflection over the line called y equals x. Now that's a line that has a slope of 1 and a y-intercept of 0, and it runs diagonally through the coordinate grid. This one isn't going to be perfect, but it's pretty close. If I reflect things over that, you'll see an interesting thing happens. Let's take a point D, for example. D prime would land right about here. And if you look at the coordinates of D, they were 1, 2 originally, and D prime turns into 2, 1. So our rule becomes the xy coordinates for each point that's reflected over this line transforms into yx, or the reverse order of those coordinates. Let's look at another one just to make sure. G would reflect over this line an equal distance from the line on the other side of the line perpendicular to the line. So it would be right about here. We'll call that G prime. If you look at the coordinates for G and G prime, once again, they just change directions from 2, -2 to -2, 2. If you have further questions about this video or this topic, feel free to contact me at this email or check out my website at Weebly.